Okay, good morning. Well, as Anna said, I'm Carlos Cordoba, and today I'm going to talk about how we, as a community, can move towards a better documentation system for scientific Python. So let's start. For those who don't know me, I am at Cordoba 12 almost everywhere, on GitHub, on Twitter, and that's also the name of my main Gmail account. Right now, I'm working as a software developer at Continuum Analytics. I'm also the current maintainer of the Spider IDE. Unfortunately, Continuum is supporting this effort right now. Before joining Continuum, I was a PhD student in industrial engineering at Los Andes University in Colombia. And I plan to come back to that next year. And finally, I have a Master in Science degree from National University of Colombia. So, why do we need a better documentation system? Well, as Fernando Perez said, scientific computing is pretty much exploratory computing. This means that any computing environment needs to offer to its users fluid and quick access to documentation. Through that, scientists can do three important things. First, they can understand by themselves how to use new libraries and new code. Second, they can discover the full range of possibilities that these libraries have to offer to their work. And third, scientists can see if they can improve or extend these libraries. And this is an advantage that we have only in the open source world. So let's see what are the current solutions to tackle this problem. So first we have the IPython Jupyter solution, which consists in using a question mark at the end of an object and evaluating that expression to get not only the docstring associated to that object, but also several other metadata like its type, its string form, and where it is defined. And with two question marks, you can get its source code. So this is pretty cool, but unfortunately, this solution is very poorly formatted, even in the notebook. So as you can see in this image, all documentation is presented as plain text. In Spider, we also have developed another solution, which consists in using Sphinx to transform docstrings written in REST and show them as HTML pages. So it's much nicer to read documentation this way, as you can see in this image, but unfortunately, we don't offer as much metadata as the IPython solution. So how can we improve this situation? I think one way to do it is by creating a new library, which I have called Grappler for docstring representations, which uses the best of the previous solutions. So it tries to use all the metadata that Python has to offer, and also the formatting that the Spider uses to represent docstrings as HTML pages. The good thing about having this as a separate library is that it could be valuable for other Python scientific IDEs like Whitehead Rodeo, Enzo Canopy, or IEP. Now, how this library works. So this library receives docstrings and metadata as a dictionary. Then it uses Sphinx to parse docstrings as HTML. Third, it adds the contents generated by Sphinx to an HTML Jinja template and uses Twitter Bootstrap tabs to organize it and present it better to its users. And finally, it returns a URL to the generated web page so that it can be shown in a dedicated web browser as Spider does, or as part of the IPython package, of the IPython pane in the notebook. Now let's see some examples about the output generated by Grappler. So first, let's see some basic examples like NumPy and lingua-lang norm. So these are shown here. For example, we have Grappler has a little function that can get the signature of a function from the docstring, as is shown here, and presented in this dedicated field. We have also the name, the type of NumPy, which is a ufunc, And the documentation, well, is rendered much more nicely. We have also here that mathematics are rendered as, LaTeX is rendered as proper math using MathJax, because Sphinx has that functionality. And doc texts are also shown properly rendered using Sphinx. But we can see here that docwrapper not only presents the docstring associated with scene, but also its class docstring. That's something that IPython also provides. And we can see more documentation about that. Here we can also see the documentation or the representation generated for the norm function. So in this case, we see REST tables generated as proper HTML tables. Also math, references, and these references point to, well, in this case, it's just a book, but it's just a book. But if it will be a web resource, it will be an HTML link here to that resource, and also, well, all docs associated with this function. This is one example. Another one, it's that docwrapper includes matplotlib plot directive as part of its code, so you can write docstrings that can show plots like this. This is the way to use the matplotlib plot directive. So before a doc test, you add this plot Sphinx directive and can show plots quite easily. This is the output of this page. It's a very simple docstring, but here we can see the plot associated with this doc test, which is very nice too. Let's see. One last example, which is a subprocess popen from the standard library. So one important thing, or one very frustrating thing about the documentation of the standard library is that opposed to the documentation used in, or the documentation found in the scientific stack, in the Python scientific stack, almost all objects in the standard library don't have docstrings. All its docstrings are very small. That's because that documentation is supposed that developers consult that documentation or read that documentation from docs.python.org. So for example, in this case of popen, we can see, as in this example, that we can get any documentation about it. So there is no docstring associated with popen, even if it has all these very least long of parameters. So docwrapper tries to get that documentation from docs.python.org. It can be seen here. These, the links to all modules and objects inside the standard library are very easy to build. So docwrapper just create an iframe and then insert the page here in this web help tab. And you can see the documentation, all the documentation associated to popen, which is very long, with just one click. So instead of Googling and going there and looking exactly what is the place of that, you can get it just here. That's another very cool thing and something that I consider that is very important too, so that people can iterate and can move faster with code, with their code. So those are the main examples of docwrapper. And I have some future ideas about it. So one idea is to add a new Dunder variable called resources to each project. This variable can contain or could contain links to video lectures or to IPython Jupyter notebooks or to things that are not easily Googleable. And the cool thing about this is that it can be shown as a new tab inside the web page generated by docwrapper, and that will be shown for all module objects. That's also a very nice thing, for example. And it's a list of links that could be curated and maintained by each project separately. And Grappler, if it finds that under variable, it will generate a new tab for it. Another important thing, but that is not going to be part of the Grappler, but that I think is important to have a good documentation system, is to have search functionality. So for that, we can use a library called Whoosh, which is a pure Python searching library. With that library, we can build an index of all packaged docstrings, and then search for something like compute average, and hopefully get NumPy mean as a result. That will be something really nice to have too, and that will make the Python scientific stack much more closer to what MATLAB and Mathematica have at the moment. This is something that was done by Robert Kent some years ago as a magic for the IPython, but unfortunately it's not working anymore. And this has some important challenges, like, for example, the index generated by Whoosh can be big, and so it should be generated in the user's computers, not distributed through the internet. And also, we will need to build a new index for each package version. Why? Because there are API changes, even, for example, in Pandas, even in point releases, there are API changes, so we can reuse the same documentation for each version, or for all versions. Okay? Thank you very much. This is